Welcome to Logic. This is Unit 2, Day 2's notes. It says mark the statements below as true or false. All students in the Glee Club are involved in an indoor activity. That means that the Glee Club has to be inside the indoor activities. So let's look at this. This circle right here is indoor activities. This big purple circle right here is indoor activities. And this green circle is the Glee Club. So yeah, it's actually inside indoor activities. So all of the students in the Glee Club are involved in the indoor activity. So that's true. Same thing has to be true if we have an if-then statement. So let's look at number 2. If a student attends an indoor activity, that one has to be the smaller circle inside this, like after the then. So inside of the then. Then the student is in the debate club. So is this one, students attend an indoor activity, is this one the smaller circle inside of it, contained in it? Is this one the smaller one? So let's look at it. Attend an indoor activity. Is this inside the debate club? No, it's the opposite way, right? So this one is false. Because some students over here, maybe students over here are in the indoor activities, but they're not in the debate club, right? Students in the newspaper are inside the indoor activities, but they're not in the debate club. All right, no students are in both the Glee Club and the debate club. That means that they're not intersecting. So we have the Glee Club and the debate club, correct. They're not intersecting, so that's true. If a student is on the newspaper, this is the newspaper, then the student is also on the debate club, right? Is that true? What about the students over here? These students are on the newspaper, but they're not in the debate club. Only some of them are in both. So this one's actually false. Only some of them. I want you guys to try the rest. Try to interpret these Venn diagrams. You have 2 left. All right, number 6, target 6. I know when and how to write a biconditional statement. So we learned about Venn diagrams a little bit, conditional statements. We can use this Venn diagram to write a conditional statement. Remember, after the if, that is the smaller circle. So after the if, we're going to say, I am an MVHS student. And then after the then, that is going to be the bigger circle. The smaller one has to be inside the bigger one. So if I am a MVHS, oops, let me do it in red. Okay, guys. Let me stay color coordinated. MVHS student. And then after the then, that's the bigger circle. Then I am part of, or I go to a Fairfax County Public School, right? I am part of, let's say go to Fairfax County Public Schools. You guys okay with that? FCPS. Okay, we learned that the converse of a conditional statement is not always true. However, they go together in pairs. If the converse is true, oops, sorry, if the conditional is true, then we have the converse, oops, I don't know what happened. And then we have the inverse, and the contrapositive. Okay, I tried. All right, if my conditional is true, then my contrapositive is true. If my converse is true, then my inverse is true. And I always like to write it that way because they come together in pairs. But if we have a conditional statement that is true, the converse is not always true. Sometimes it is, but not always. So we're going to, when they're both true, we're going to make a biconditional statement. So it says, in the case where the converse of a conditional statement is true, when the converse and the conditional statement are both true. So the original is P arrow Q. That's my conditional statement. And the converse is the flip, Q arrow P. When they are both true, then they can be combined into a single true statement called a biconditional statement. So that just means that it goes both ways. And we have the symbol for a biconditional statement, which is P, and then arrows on both sides, and then Q. This means a biconditional. Both ways are true. I want you guys to put a star by it. Underline this and put a star by it. The biconditional is formed by joining the two parts of the conditional with the words if and only if. And mathematicians love to abbreviate this, and we use IFF. So IFF means if and only if. Okay, so this is what it means. My conditional is if an angle is a right angle. This is my hypothesis, and angle is a right angle. My conclusion is it is equal to 90 degrees. The opposite also has to be true. If an angle is equal to 90 degrees, then it is a right angle. You guys see that we just switched them? We switched the order. That's my converse. Now I can rewrite this as a biconditional statement. An angle is a right angle and then we can write if and only if, or IFF. You can write it out. If and only if it is equal to 90 degrees. And underneath if IFF, write it out, if and only if. Write it out so you remember. Let's do the next one. It says two angles are supplementary if and only if their sum is 180, right? Rewrite this as a conditional and its converse. So remember, a conditional always has if and then in it, and the converse always has if and then in it. So we're going to say if, I don't know why it keeps on going down. If two angles are supplementary, comma, then their sum is 180. Notice we've been using a lot of geometry terms that we used last chapter, but all geometry theorems are biconditional, or all mathematical theorems are biconditional. Now we're going to do the converse, the opposite. So the first one was, if two angles are supplementary, then their sum is 180. We're going to flip it. If two angles sum is 180, then they are supplementary. Just flip it. That's a definition. We know that. That's what it means to be supplementary. Two angles that add up to be 180. And those are both true. So these two are both true, and these two are both true, which makes it a biconditional. Go ahead and flip your paper over. Let's go to page 2. Example 3. So it tells you that math definitions are always biconditional. I just said that. It says two lines are perpendicular. This is a symbol for perpendicular. Please underline that word perpendicular. That means that they meet at a 90-degree angle. Well, that's what it means, right? So if two lines are perpendicular, if they intersect to form right angles. So rewrite this as a biconditional statement. We're going to say two lines are, and let me use a symbol for perpendicular. You guys can write it out if you want. The upside down capital T. If and only if, you can write it out if and only if they intersect to form right angles. All right, go ahead and go down. Each conditional statement below is true. Write the converse. If the converse is true also, combine the statements as a biconditional statement. So I'm going to help you with one. You're going to do number two. So it says, is that all it says? If the converse is false, provide a counterexample. Perfect. Okay. It says, if two angles are vertical, then they are congruent. Is that true? Vertical angles are congruent. That is true, right? Well, let's look at the converse. Remember, my hypothesis is after the if, not including the if, guys. And then my conclusion, circle your conclusion, is after the then. I want you guys to do this to number two also. So my converse, we're going to flip it. My converse means my conditional is P arrow Q, and my converse means to Q arrow P. We're going to flip it. So converse is if two angles are congruent, put the congruent symbol above it, an equal sign with a tilde, right? So if two angles are congruent, comma, then they are vertical. Well, my conditional statement was true. This one, number one, was true, but my converse is not always true, right? So not all angles that are congruent have to be vertical. All vertical angles do have to be equal, right? They're congruent. So these two angles measures are equal. If the top one is 30, then the bottom one is 30. However, I can give you an example of angles that are equal, but they're not going to be vertical angles. Let's give an example. Maybe a pair of adjacent angles, right? These are not vertical, they're next to each other, so they can't be vertical. And I can make them congruent by just putting a congruent symbol in there. A little arc means that they're congruent. So these arcs, write it down, arcs show congruency, right? And they're equal, but they're not vertical. So that's my counterexample. I want you guys to try number two. You guys try this one. Oops. Decide if the original biconditional is true or false by rewriting the two statements that form each biconditional. If either statement is false, then the biconditional is false. So remember, both have to be true for this to be true. So I'm gonna underline or circle the if and only if for you, because this is where we're gonna put the then. So we're gonna say, if it is winter break, then with a circle, you do not have homework. And if you do not have homework, then it is winter break. So we're gonna have to rewrite both. If is this true or false? If it is winter break, then you don't have homework. It should be true. No one should be giving you homework during winter break, right? So this should be true. Now let's look at the converse. We're gonna flip it. So if you don't have homework, oops, comma, then it has to be winter break. Is this always true? Is it always true? What about on the weekends? Sometimes you don't have homework on the weekends, unless you're an IB student. Maybe you do. But what about summer? During summer, you don't have homework. So we're gonna say this might be false. Okay. And my counter example, remember we have to give a counter example. Don't forget, my counter example is summer vacation. Write it down. Good. I want you guys to try the third one, or the fourth one. Try it out. So I'll rewrite the conditional and the converse, and then tell me if both are true. Okay? And I will see you in class tomorrow morning. Have a great night.